Welcome back to R Programming 101. We're going to be talking about data visualization, and in particular, we're going to be talking about how to use ggplot. Now, to use ggplot, you need to get your head around a different way of thinking about graphics. But once you get familiar with this, once you get comfortable with it, you're going to absolutely love it. All right, so let's get stuck in.
If you want to learn about R programming, then you have come to the right place. On this YouTube channel, we're creating R programming videos on everything.
So when we talk about the grammar of graphics, we try to define certain parameters of a given data visualization. And in this video, I'm really going to talk about the top three, these three: data, mapping, and geometric representation. Just briefly, obviously, the data we're going to tell R what data set we're using. Secondly, the mapping. This is where we take the values within any given variable and we tell R what to map them out on our canvas with respect to a given aesthetic. What do I mean by that? I mean, we might say this variable will be mapped out against the x-axis. This variable will be mapped out against the y-axis. This variable might be represent color or shape or size or something like that. And then the geometry or the geometric representation is, do we want this to be a line graph, a dot plot, a bar chart, a histogram? We've got to tell R what kind of geometry to use. Okay, and the best way to understand this really is to do a couple of examples, and you'll see exactly what I mean. Now, the one thing to remember about R is that it's got built-in data sets, and I'm going to be using those built-in data sets to do the data visualization that I'm going to do in this video and in other videos, so that you can, back at home on your own computer, replicate what it is that I'm doing, but then also get creative and use the same data to produce different and better and more interesting data visualizations, plots and graphs. Okay, so to see what data sets exist within R, of course, we just type in the word data, open and close brackets, push enter, and we get a list of all of the data sets that are built into R that you can use for practice. Okay, and that's what we're going to use. Right, so if we look at the data sets that are built into R, we've got one here that's called BOD, biochemical oxygen, right over there. And if we go back into our source and we type in the word BOD, up will come the data set itself. Let's just make this a little bit bigger. There it is, time and demand. We see there's 6 rows, 2 variables, quite simple. If we put a little question mark in front of the BOD right there and push Control Enter, in the help section over here, we'll have a description of that data set, including a description of each of the variables, right? I'm not going to get into that in this video because we're really interested in how to visualize this data and get into the graphics, okay? So let's get stuck right in. Okay, so let's talk about ggplot, right? We're going to start off just by typing in ggplot, open brackets, and then we said the first thing we want to define is the data. So we say data is equal to, and in this case, the data is going to equal to BOD, right? That's the data set that we're going to use. The next thing we want to define is the mapping. And I'm just going to go to the next line here, but it's the same as carrying on. It's just a matter of it looking a little bit neater. And we can type in mapping is equal to, and then we want to do AES for aesthetics and open brackets, right? Now that seems a little bit complicated. You'll get used to it. It's not that complicated. Once you've done this a few times, it'll just be like eating breakfast in the morning, right? Mapping equals aesthetics, and here we want to define X is equal to, right? And what were our variables that we had down here? We had time and demand. So let's say X is equal to time, comma, and I'm just going to go down a line just so that we can see what's going on here, and Y is equal to demand. Right, now by convention, usually our x-axis is our independent variable, okay, and our y-axis is our dependent variable. In other words, if we think demand is a function of time, as time goes along, demand goes up or down. Demand is dependent on time. We usually put demand or the dependent variable as the y variable. Now, if I pushed Command Enter at this point, let me do that for you, Control Enter at least because I'm on a PC. It has created a canvas with nothing on it, right? But it has mapped out time as the x variable, right? And demand as the y variable. Now, the next thing we can do, I'm going to make a little bit of space over here, is we want to tell it about the geometry. So if I push plus, okay, because we're going to add something to this now, push Enter, and I'm going to say geom point, open close brackets. I'm leaving what's inside the brackets blank for now, right? We're going to add some stuff to that in just a minute, but we're just going to leave that blank for now. And I push Control Enter now. It's going to redo the graph, and it's going to pop little points at the various places that map out against time and demand, right? Now we can put something in there. We might want to say size is equal to 5, for example. Okay. And it'll make each of those points a little bit bigger. And we can add another layer to that. And we might want to say geom line. And we might say color is equal to red. Okay, I'm just going to revise what I've done there, and then I'm actually going to do it again in a slightly different way, just so that you can really get your head around these 3 components of data visualization. These are the most important 3 components of data visualization. After that, you can create layers and add in themes and do all sorts of exciting things, but you've got to get this right. These are the most important 3 components of data visualization. Right, so we've said ggplot, data is equal to BOD, we've defined the data set. Then we've said mapping, and we've said the aesthetic X is going to, the X-axis is going to map out against time, the Y-axis is going to map out against demand, and we've defined 2 geometries. We've asked it to create points and lines, and then within the brackets we've created a little bit of information about what, you know, the size and the color, but that's less important, right? But that, I just showed you what you can do, but that's almost besides the point. Right, let's do this entire process again. And I'm going to build it up again. I'm going to do a slight variation on what I've done that'll just get you a little bit more comfortable with the whole process. Okay, so let's delete all of that. And this time I'm going to say ggplot. And I'm not going to say data equals BOD, but I'm just going to say BOD. And the reason is ggplot will assume that the first argument is the data frame, right? Then I'm not going to say mapping is equal to, I'm just going to say aesthetics and open brackets, because ggplot assumes that the next argument is the mapping. And now I'm not going to say X is equal to time. I'm just going to put in time, and I'm just going to put in demand, because ggplot is assuming that the first argument will be your X axis and your second argument will be your Y axis, right? And then I'm going to put plus, because we want to add in some geometry, and I'm going to add in geom point, open and close brackets, and then add in another layer, geom line, open and close brackets, command enter. And we're going to draw that graph, right? And now I'm going to say, ooh, those dots are a little bit small. I'd like them to be a bit bigger. Size is equal to 3, let's say. And I'd like the line to be red. And when you put in, if you want to just put in the word red, you must put it in inverted commas, right? Control enter, and we've got more or less the same graph that we drew a few minutes ago. Give it a second, there it is. Okay, that's not too complicated. We're going to do some other graphs and you're going to understand some of these parameters, and we're going to build things up a little bit more. This is exciting times. I hope you're enjoying this video. There's more to come, don't go away. Right, now we're going to do another graph using a different data set. So let's jump in. If we type in the word data, open and close brackets, enter. Here's another data set called CO2, carbon dioxide uptake in grass plants. I know nothing about grassy plants, but let's have a look at that data set. If I type in CO2, command enter, there we go, it's got 84 rows. I could do this, I could do view, open brackets, CO2, close brackets, and we're going to then see that data set up here. There it is. We've got a couple of variables. We've got plants, we've got the type of plant, we've got a treatment that was given, and I believe this is chilled and non-chilled, concentration and uptake. Right. I'm not going to get into a big discussion about what each of these variables means. You can do question mark CO2 and read about that. Let's get straight into the data visualization. Now, we said before that we can start off, let me make a bit of space here, we can start off with ggplot, and we can type in CO2, and that's the data frame that it's going to use. There's another way to do this, and it's kind of quite exciting. You can type in CO2, and then because we're working in the tidyverse, we've got access to the pipe operator, right? You've seen this before. Okay, the percentage greater than percentage. And the pipe operator means it'll take anything from the left-hand side of the pipe operator and pipe it in as the first argument into the whatever's to the right of it, or in this case below it, because I'm going to push enter, right? So if I push CO2, pipe operator, and then ggplot, open brackets, ggplot already knows what data set it's using. So we don't need to say data equals CO2. We don't even need to say CO2. CO2 is piped into ggplot, and we can carry on and we can make the first argument that we define the aesthetic. Does that make sense? Right, and just so that I can remember what the different variables I've got, I'm going to go right down into the console over here. I'm just going to type in names, CO2, close brackets, control enter, and that's just going to give me a list of the different variables that I've got. So I'm going to want to say my x variable, in other words, my independent variable, I'm going to say is concentration. That's the concentration of CO2 in the atmosphere, I'm guessing. And I want my y variable to be uptake of CO2, right? And I think that's the dependent variable. And then I'm going to say, I'm just going to put an enter here just so that you can see what's going on, but you could carry on to the right. The next thing I'm going to say is I want color to equal the variable treatment. In other words, I want, as things get plotted, I want the color of individual plots to be a function of which treatment group that particular observation or row was in. Okay, and then I'm going to add plus because I want to add in some geometry here. And let's make the geometry that we create geom point again. And we won't do anything with it at the moment. We'll just push Control Enter. Right, and there we've got the beginnings of a graph. Not bad, but there's a lot we can do with this. What I want you to see here is that we've included color equals treatment as part of the arguments in the original line for ggplot. In other words, this fact that color is mapped out against treatment will apply to every layer that we produce. If we put a line in here, there's different layers we can add here, this parameter will always apply. We could have put color equals treatment in here, right, as part of the aesthetic in here, and then it wouldn't apply in the next layer, but we wanted it to apply to all of them, and you'll see why in just a second. All right, so let's just say for argument's sake, we'd actually like these dots to be a little bit bigger, and we can also say we'd like them to be a little bit transparent. So we can actually say alpha equal 0.5. That'll make them slightly transparent. That's fine. And then I'm going to add to that, right, another layer, and this is called GMSmooth. And that's kind of quite a nice way of producing a linear model that'll map over our GM point. Okay, and just to let you know what's happened here, it's drawn two smooth linear models through these two groups, the chilled and the non-chilled, these treatment groups that were applied to the grass. I don't know much about grass. And then around each of them, it's drawn the standard error. You can see they overlap a little bit over there. We might sort of say, look, actually, what we want to use, now we can add in some arguments into the GMSmooth. We can say we want the method to equal a linear model, and we want the standard error equals false. So we don't want it to draw the standard error. Let's see what that does. And then we can create a facet wrap by type. We might want to divide this out by type a little bit. Okay, and we can see now we've got the Quebec, we've got Mississippi. These are the two types. So we've created two facets by type. The colors are still being mapped against the chilled or not chilled. In other words, the treatment groups. We've got two layers. We've got the points, and we've got the linear graph over that. So we've got quite a lot of information all on one graph so far. Now we can add in a label if we want, right? Labs. And here you can add in labels for X and Y, but all I'm going to do is do the title. And I'm going to say concentration of CO2, for example. And then what I might do is add in a theme, and I'm going to make it the black and white theme, which is kind of quite nice. Let's have a look at what that looks like. Okay, voila, quite a nice graph. I'm going to use the same data to draw another graph using a slightly different approach. Okay, now I'm going to use this again, right, the CO2 data set. I'm going to pipe it into ggplot. And this time, I'm going to set treatment as the mapping against the x-axis and uptake against the y-axis, right? Then I'm going to add, again, and that makes sense, right? Because whether you get treated or don't get treated with, you know, this chilled or not chilled could be seen as a independent variable, right? It's the causative variable, and it is a determinant of uptake in this case. Right, now we add in the plus, and we might want to create a box plot. Okay, so GM box plot. Okay, so we'll start off and have a look at what that looks like. Okay, I spelled the word treatment wrong. Let me just put an R in there. Right, now I've got update instead of uptake. So sorry about that. Okay, now we've got a box plot, right? Not bad, but I'm sure there's a lot more we can do with this. So let's take a look at what we can do to make this a little bit more pretty. I'm going to layer on top of that a GM point. Okay, let's start off with that and have a look at what that looks like. And now I'm going to add in some mapping just for the points, right? So now if I say aesthetic, open brackets, right? And I want size to equal concentration. And I want color to equal plant. And you'll notice, and now I'm going to push Control Enter. Now what's quite important about this is the mapping that I did under GM point here only applied to the points. It didn't apply to the other layers of this particular graph. Right, so you can stick in this mapping in the original ggplot set of attributes or in the geometries, and that's quite important to notice. Now in this geometry, GM point, I've mapped out size against concentration, color against plant, but there might be some attributes that don't map out against a variable. They're just an attribute we want to be part of that particular geometry, right? So in this case, alpha, which is how transparent something is, I'm going to add that in. I'm going to say alpha is equal to 0.5, comma, and then the rest of it can be, well, I'll push enter. The rest of it can be like that, right? Push Control Enter. Bada bing, bada boom. Okay, and there's still more we can do. Why don't we flip this on its side? Code flip. And I might want to give it a theme. I like the black and white theme. And now I might want to say, look, why don't we get some more information out of this and do a facet wrap by type. Right, so we've got, let's stick in a heading. And we're going to call this heading chilled versus non-chilled. Right, and that's the same data that we used before. We've just organized it in a different way. We've visualized it in a different way. We can zoom in on that. And we've got a number of different attributes that are being represented here, right? We've got the type of plant, Quebec and Mississippi, or I think the actual name of the designation of the plant itself, the concentration, we've got uptake, we've got treatment, we've got a lot of attributes all summarized in one graphic. Absolutely beautiful. Now, just so that you know, you can export. Obviously, you can just save it as an image, save it as a PDF, copy it to clipboard, or you can use the ggsave function in ggplot, save it to your hard drive. But even better than that, you can do this whole thing so that the graphic gets embedded straight into a PDF or a Word document. Okay, let's do one last graph. Well, again, using data that's built in, right? And this is going to be the miles per gallon data set. Control Enter to have a look at that. Here it is. quite a big data set, so why don't we do this? Let's do view and have a look at that data frame. Here it is. We've got a number of variables. These are different cars and models, and displacement is engine size, and this is city and highway fuel efficiency, so it's miles per gallon, right? So we're going to think, we might think that the engine size, this displacement, might be the x variable, or the independent variable, right? It is the causative variable, and the engine size may translate into better city and highway fuel efficiency. So let's take a quick look at this. Right, so we start off, let's make some space here. Right, miles per gallon, and this, I'm going to show you in a few seconds why it is that I think it's important to pipe the data in as opposed to just going straight into ggplot. So we're going to pipe it in to ggplot, and in this case we're going to say our x-axis, our independent variable, is going to be displacement, and our y is going to be fuel efficiency in city driving, right? And we're going to add into this a geom point. Okay, and we'll start off with that and have a look at what that looks like. Okay, and we see there seems to be a relationship. As engine size gets bigger, fuel efficiency goes down. But let's add a little bit to this. Let's say for these geom points, we want to add in an aesthetic where we map color against the drive, four-wheel drive, front-wheel drive, etc. And the size of the dots to the transmission. Okay. Okay, that's quite bright, so why don't we push enter and say alpha equal to 0.5, just to make it a little bit easier to look at. Okay, and we forgot to put a comma over there. Okay, that's a little bit better. We can see the green are the front wheel drives, the reds are the four-wheel drives, and the blues are the rear-wheel drives. The size of each dot is a function of the transmission type. Now let's add a layer, and now we're going to add in another geometry, GMSmooth. This is a smooth linear model, and method is equal to linear model. Just so that you can see, if I didn't say method equals linear model, if I left that alone, it would do a smooth model. And you can see the standard error is around it over there. And if we add to this a facet wrap by year, and we're going to say the number of rows is equal to 1, because I want them to all be on the same row so we can look at them. Okay, we've got 1999 and 2008 compared to each other. If we pop in this method is equal to linear model, it might be a bit nicer. Okay, now let's go back. Let's say, look, these are all outliers up here. They're just muddying the water. What if we said we want the city data to be filtered by only rows or observations that are less than 25? We could go up here. Because we're using the pipe operators, we could say filter, and we would say city is less than 25, and then pipe operator, and we're piping in some new data into our ggplot that now has a filter attached to it. And there you go, voila. Okay, now we can add some labels, plus labs for labels, right? We can say x is equal to engine size, y is equal to miles per gallon, or need inverted commas, miles per gallon in the city, comma, title is equal to fuel efficiency. Now I'm going to add in a theme. I like the black and white theme. We could go, actually, there's another nice one that I like. It's this theme down here somewhere. I think it's called Minimal. That's kind of nice as well. Actually, no, let's go with black and white. Black and white for this. Enter. Let's have a look at that. Right, and voila, we've got multiple aspects of our data being represented. We're using size, we're using color, we're using facets, and we're using both of our axes. So we've got a lot of aspects of our data all being represented in one very nice graphic. Okay, I hope that was useful. There's many more things we can do with ggplot. I'm not going to get into that in this video. What I wanted to do here is just introduce you to these ideas, to this idea of the grammar of graphics. Do a couple of examples using data that you have access to. All of the data that I've used, you've got that data. You can do these exact same graphics on your computer at home and then play with it. Try different things. Try adding on different filters. Try and use the variables in different ways. And the more you play with it, the more you experiment with it, the better you're going to get at producing graphics that are consistent with your style, the way you want to communicate, and you're going to get really good at it. You're going to have a lot of fun. So hope that was useful. More videos to come. Don't be a stranger. Take care. Don't do drugs. Always do your best. Don't ever change. Bye.